give a little, I remind what we have done it early. We explain about the pressure applied by the solid objects. Pressure equals force divided by the area. In that equation, we have done some calculations. We have done that. The liquid pressure H rho G, right? And you may get many questions out of that. Is very important for the O-level exam. Also, we have discussed that liquid pressure also there, and we have done some calculations. And the vehicle hoist question also there for the O-level exam. These questions are possible there. Hydraulic vehicle hoist and some examples for liquid pressure applying motor vehicle hydraulic brake system and the hydraulic jack for the motor vehicles. And the Archimede's principles I explained as the upthrust when the object is because floating in a liquid, children, it applies an upthrust on the object there. Right? The upthrust, when it is floating, upthrust is equal to the weight of the object. When the upthrust is smaller than the weight of the object sinks. In all the cases when the object is floating, upthrust is equal to the weight of the object. That's a important thing that you have to understand. Right? Rough idea. Sorry, it's smaller. Okay. What's the rough idea you have to get? When an object is floating, the upthrust equals to the weight. When it is sinking, what happens? The upthrust is smaller than the weight. That's why it is coming down. Down 7 Newton, up 7 Newton. Down Newton, up 7 floating. But down 7 Newton to upward 6 Newton, it is coming down and sinking there. Right? And another thing I explained there, one thing I explained there, when the density is smaller, right? Because low density one, right? Upthrust is smaller. It's applied a little upthrust. When the density is greater, children, it is floating much up. The density here. This the density is greatest density. This object is here. When the water density is less than the density of the glycerin, in that case partially sunken. If another one less than the water, it is completely sunken. Here, this kerosene very low. In that case, it's unable to apply a good upthrust there. And some questions also we have done. Still we are explaining the last, what we have done last week. This object 7 Newton. Actually, its volume is 125 cubic centimeters. We immerse in the liquid. In that case, displaced volume of water that's equals to the volume of the object, 125 cubic centimeters as same. And the earlier weight was 7. The liquid applies a 2 Newton upthrust. In that case, it is giving the 5 Newton. 7 became 5 children. Why? Because the liquid applies 2 to upwards. When the size of the upthrust is 2 Newton, that is equals to the weight of the displaced liquid. That's the most important thing there that we have to know. Again, I gave some questions as a homework. Right. We will discuss from here now. Well, shall we start the lesson now? All right. Okay. This is the question I gave. I think you have answered it. Study the setup shown below and answer the question here. At some parts done or not, I just erase from the beginning. We will do. All right. Now, as a homework, I'll give one object is there, children. Study the setup shown below and answer the question below. This knowledge, children, you have to get it to your brain. Mainly, you have to get the concept of this, right? Because you can find the earlier weight of this object is 10 Newton in the air and the volume 8 cubic centimeter. Now we will partially we control, we will place it in the liquid, and a certain amount of water is displaced there, right? Maybe the half it is again. Now completely it is immersed in the liquid. Then total amount of that part is there, right? You can get it there, right? And again it's still a mistake. How can we get this not? Right. Oh, anyway, like we'll do that. Right. Then what can we get it? Oh, it's not the. It's a mistake there, right? Get it. It's wrong expression there. Okay. Then look at here. It's a 10 Newton there, and the volume is 8 cubic centimeters, right? 8 cubic centimeters, and we make it half there, right? Partially, half we immerse that. Then half of the liquid is moved out. Here also, children, because one a certain amount of liquid, the full total volume of liquid is there, right? And fill in the blanks marked in the diagram, children, right? Here you can find, children, you can start from this one, right? It is completely immersed. Then in that case, volume of this displaced liquid equals to the volume of the object. Volume of the object 8 cubic centimeter. We can write the 8 cubic centimeters here, right? 8 here. Because it is floating there, children, right? Weight is 8. Because it is completely floating, that is, it is applying an upthrust, right? They are completely filled there, then it is upthrust equals to the weight of the object. Weight of the object 10 Newton It is, we can write as the 10 Newton. Weight of this liquid 2, right? Okay. That is 10 Newton, right? In that case here, what should it be? It is 0, because weight of the object 10 Newton. Then we are giving the upthrust also up to the 10 Newton. In that case, this value becomes the 0. Another liquid one, it is floating children partially, the half, another liquid there, right? It is much denser. In that case, even the little half there, suppose we tell as this one 8 cubic centimeter, we tell it as the 4 cubic centimeter there, as roughly 4 cubic centimeter, right? Suppose partially half there. But it is floating, we can tell, partially floating. But the weight to float children like that, the upthrust should be equal to the weight. Right? In the liquid one, also, even the smaller one is a high denser liquid, but weight of this liquid also same as this one. Why? It is floating children. So two liquids, not the same liquid, right? Keep it in your mind, not the same liquid, two liquids. This one high denser children, right? When it is floating, a half there. Right? In that case, we can tell that one also 10 Newton. This one. Volume children, 4 cubic centimeter, half a partial area. But actually, weight of this displaced liquid equals to the upthrust. They are applying an 10 Newton to up. Then 10 Newton to up means children, weight of the object also 10 Newton, this also becomes 0. Like that we can fill it. Very carefully do, because we have to do it with our mind. Was the liquid more denser, liquid 1 or 2 children? I have said the answer. Which liquid is much denser? Anybody? Jonathan, which liquid is much denser? Liquid 1. Liquid 1 is much denser because it's a smaller volume but high weight. It's a large amount, same weight. In that case, this is. But in the when the liquid is much denser, with a small amount of liquid enough to apply a greater upthrust. Liquid 1, correct. But the main thing, you have to get the basic idea, children, right? Because actually we can't guess what the question is coming, right? But to if you get the basic concept, any question out of this part you can answer, right? You find the many past papers, question books, and find the more and more question on this lesson. Explain scientifically. An iron nail sinks in water, but a large ship made of iron floats there. What happened, children? How can you explain? Is anybody has answered it, children? If you have answered, you tell. Any body you can tell this?
They add that gas inside a ship is much denser than water.
can't there's a much space here, right? In that case, you can understand because iron nail is a completely solid object, right? But it is having what's that? Saying a much solid. It's a solid object, right? In that case, no air inside that. It is much denser. It is denser than the air and silky, right? And if you get the ship children, it is having a more space with the air. In that case, if you get the total object, the ship there, it is less denser than the water. In that case, it is that's another thing. That's also correct. What is the other one, children? Right? That's one thing. The other one I'll explain. If you get children because of the shape of the ship, right? I just draw a ship. Yeah, right? Can you get it? And we get the shape of the liquid. Okay. Now I am just drawing the water there. According to the Archimedes principle and the density in the both, we can tell. When we drop the ship into the water, children, a certain amount of water displaced here, children, because of this volume, right? According to the shape, that's the suppose a certain volume of displaced certain volume of water because it is a ship is made of wood, right? Or metals there, but more air space there. This is the volume of displaced water. Right? Suppose this is the volume of the displaced water, children. Right? 500 Newton. Oh, we just tell 500 Newton. 500 Newton. The weight of the ship also, children, 500 Newton. In that case, it is floating. Large volume of, according to the shape and the design of it, because more air inside that. In that case, the displaced volume of water, children, because of the ship when we are dropping into the sea, children, right, that's also equals to the weight of the sea. But if you because I also had the very smaller one, because iron nail, very small object, children, an iron nail. Completely solid object, children. The certain, when we drop it in the water, children, right, a very little amount of water is displaced here. Right? Very little amount of water displaced. Suppose we can tell 1 Newton, right, amount of water displaced because of the iron nail, right, according to the volume. Right? Volume. But volume of is smaller, but weight is greater, children. This iron nail, weight of the iron nail, children, 2 Newton. Right? The displaced volume of this mass of the, weight of the displaced water because of the iron nail 1 Newton. Weight 2 Newton, in that case upthrust equals to the weight of the displaced water. Upthrust is children 1 Newton. 1 Newton up, 2 Newton down. Iron nail sinks. But a ship, what that? Weight is 500 Newton. Weight of the displaced water, because according to the design and the structure, that's also 500 Newton. Sorry, that's the 5,000. The 5,000 I just mark as the 500. That is also 500 Newton. Then weight 500 Newton. Weight of 500 Newton to down. And the upthrust also, children, 500 Newton to up. Then this ship is floating. Right? That's according to the design and the structure. Right? And the volume, because actually, because of the shift, children, volume of the displaced liquid is equals to the volume of the ship. Sorry, weight of the ship. And the weight of the displaced water is equals to the weight of the ship. The weight of the ship 500 Newton, and the weight of the displaced water also 500. In that case, weight of the ship and the weight of the displaced water balance. Ship is floating. If you get the iron nail, children, it's a very solid object, children. Right? In that case, but that much denser solid object, right? Completely compact solid object, then displace water 1 Newton. The weight of the iron nail 2 Newton. In that case, it is weight is greater than the upthrust. The displaced liquid is 1 Newton. In that case, upthrust is 1 Newton. Right? A small volume of water displaced there. Right? In that case, small upthrust. But the weight is much. But here, large volume of water is displaced. In that case, large upthrust. Have you understood that, children? Okay. Have you understood the basic theory?
Yes, sir.
Okay. Then I will write the answer there, children. If you need, you can write this picture also there. According to, right, because we first write and later draw the diagram, right? Please write with me, right? According to the design and shape, the ship displaces a large volume of water. Large volume of water. Write down. Next one. As the weight of this displaced water, weight of this displaced water please write with me, is equal to the weight of the ship. But do not write weight of as the weight of this displaced water. That means we write within bracket, you write upthrust. The weight of the displaced water is the upthrust. Upthrust. Okay. That is equal to the weight of the ship. Come on. The ship floats, right? Then we consider the iron nail, right? The displaced, the volume of displaced water, by iron nail is small. It's a low volume, right? Low volume. And the weight of the displaced water, that means the weight of the displaced water means the upthrust, is less than the weight of the iron nail. Less than the weight of the iron nail. Right? Iron, right? Right? As weight of the iron nail is greater than the upthrust as the weight of the iron nail is greater than the upthrust, the iron nail sinks in water. Come on. Right. Finish writing, children? And please draw the diagram. It got a little time to explain that. Understood it, children? If you get the iron nail, weight 2 Newton, it is much down, upthrust 1 Newton. In that case, weight is greater, it is sinking. But if you get the ship, children, weight 500 Newton, upthrust also 500 Newton floating. Why? It gets a greater upthrust. It's according to the shape, it displays the larger volume of water. In that case, weight is greater. But this one displays the little little volume of water. In that case, weight is less. It is less than the displaced water. The weight of the displaced water is less than the weight of the iron nail.
Yes, sir.
Finish all finish writing children there? I have given, I will go to the next question. Study the diagram below that explain immersing an object in water. Right? To study the upthrust by water relevant to the Archimedes principle. Answer the question, right? Now it is completely sinking an object. It's 8 Newton there, right? When the weight, when it is in the water, it is they have got 8 Newton there. That's a 300 cubic centimeter. They have got another thing here, right? Not floating children, that one, right? Something, right? If it is floating children, it will go to the 0 children, right? It's floating, but not floating children, right? But it is hanging here, right? The earlier one children I gave this one. They became 0 children. When it is floating children, this value gets 0. Right? If it is floating, it is get the 0, but the question also I have to set the 0 there. But it is floating. That one children, not floating children, but it is hanging there. Right? If it is floating children, weight equals to the upthrust and it is getting 0. Right? This idea you have to get. Right? If it is floating, this part also, because weight equals to the upthrust. But if you cut these children, it will go down. Study the diagram below that explain immersing an object in water. To study upthrust by water relevant to the Archimedes principle and answer the questions. Right? It's a volume of is 3 cubic centimeter. In that case, this volume also will get at the 300 cubic centimeter. I will mark it also there. Because you have to understand it with the brain, children. Right? 300 cubic centimeters. Right? Weight 3 Newton. In that case, upthrust they are applying the 3 Newton here. Just applied 3 Newton. What's the volume of displaced liquid? That I have marked that. What's the volume displaced liquid, children? Please tell me, children, because actually your responses are much important at the lesson. What's the...
Centimeters.
Yes, 300 cubic centimeters. 300 cubic centimeters. That's the displaced volume of the displaced liquid here equals to the volume of the object. Right. But the weight of the displaced liquid we have marked here. Yes, it is 3 Newton. Right. What's the size of the upthrust?
8 Newton minus 3 Newton, 5 Newton.
Right. Any other answers? Sajini? Oh, Pavani, you answer? You spoke there?
3 Newton.
How many newtons?
3 Newton.
3 Newton. Correct. Right? Because actually I told upthrust is equals to the weight of the displaced liquid. Upthrust equals to the, because we check whether you have got the concept. Upthrust is equals to the weight of displaced liquid. There's a 3 Newton, children. And please refer the last week lesson also there, children. From the beginning, little by little, I'll explain. This we get the displaced liquid weight equals to the upthrust. It's a 3 Newton. It's applying a 3 Newton upthrust to here. 3 Newton. Right? When you, even after applying the 3 Newton here, it is 8. Right? There. Okay. What's the weight of the displaced liquid? 3 Newton. In that case, upthrust also 3 Newton. Upthrust equals the weight of this displaced liquid. Right? Please mark that 3 Newton. That means the weight of the displaced liquid. Right? Because actually to give the basic concept, I add. But the mass of the displaced liquid. Right? There's also something like we have with the weight. Right? We have an equation, children, to teach that I have added. Have said anybody answered that part, children? Mass of the displaced liquid. Right. Because we have an equation, children. Right? Because to teach that also I have added that W equals MA. Right? MA. Here W means, children, weight. M equals the mass. A means acceleration due to gravity. Please write with me, okay? Due to gravity. Right. A, acceleration due to gravity. When we get the W equals MA, the weight, right, equals to the upthrust. Right? Right? What's the mass of the weight? Here, weight of the displaced liquid, 3 Newton. Then we can write that one, 3 Newton mass and acceleration due to 10 meters per square second. Mass, to find the mass, children, we go to the 10 to the other side, then mass equals 3 Newton divided by 10 meters per square seconds. That equals, children, 3 divided by 10, 0.3. SI unit for the mass, children, kilograms, 0.3 kilograms. Some questions, these kind of things are also coming, children. Right? Those are the physics. Please get also into your mind as the right teachers, special gift like I am giving as a Guru Mushti like that. When the question, not only the upthrust, other things are also adding at the O-level exam. Right? Then next part, calculate the density of the water according to data collected by this experiment. Has anybody have you done that? Has anybody done this? Pavani, have you done? Sajini? Nobody speaks. No. Yes or no? Even
Yes.
no? Yes. Pavani, what's the density you have got?
Cubic centimeter.
Because mass, density equals density equals mass divided by volume. Mass we get as 0.3 kilograms, and volume, children, they have got there. Right, 300 cubic centimeters. It has given with the cubic centimeters, children. Right? Or we can get it as the if it is given the cubic centimeters, easily with the grams, we have to convert this one into the grams there. Or cubic centimeters, we have to convert into the cubic meters there, children. Right? I think sometimes it is easy converting. That is converting kilogram into the grams. Right? In that case, 0.3 kilograms means, children, we can get this as the 300 grams, right? We can get it as 300 cubic centimeters. Cubic centimeters. So we can convert it to there. Then kilograms, the grams per cubic centimeter we can get. The 0.3 kilograms means the 300 grams. That means volume 3 by 300. Answer we can get as 1 grams per cubic centimeter. This is one method, right? You can mark it if you have any another method with the cubic meters, where we have to convert 300 cubic centimeters, right? Right, 300 cubic centimeters, children, into the cubic meters, right? Like that I can show you like that. 0.3 kilograms divided by, in that case, if you convert the 300 cubic meter into cubic centimeters into the cubic meter, 0.0003 cubic meters, right? We can get that. Then 0.3 divided by this value, children, we can get answer as the 1000 kilograms per cubic meters. Right? Like that, there are two answers, children, we can get. Right? That means, children, because how did I convert 300 cubic centimeters, children? 300 cubic centimeters means, children, because cubic centimeter means the 3 times centimeters, children. Cubic centimeter, 1, how it became. Actually, it is rough. With your mind, you have to understand, right? 300 cubic centimeters means, children, it is multiplying cubic means 3 times multiplying. That means the height, width and the length, right? That means, children, 300 into centimeters, again centimeters. To convert centimeters into meters, children, we have to divide it by 100 children, 100 centimeters per meter. In that case, it is dividing by, right? To convert the centimeters 3 times, we divide first centimeters, convert this centimeter into meters by dividing by 100. Okay. And second centimeter also we converted into the meters dividing by 100. 100. Sorry, not 1000. 100. And third cubic centimeters, third, like this one of the, see, cubic, right? This third centimeter also, children, we converted into the meter by dividing 100. Then 300, this one, it get cancelled. Then, but that with this one, children, we get the point. Then how many? 1, 2, 3. Point. There are 3 parts are there. 1, 2, 3. In that case, it is become 0.0003 cubic meters like that. Okay. We can get 300 divided by. With the first 100 it is going. This one came decimal point. Another. Yeah, right. That's how we have done, right? Because this is full of children mathematics. Only. Have you understood it, children? Or not? If not, please tell me. I'll explain taking extra page and larger. Have you understood it? Or not?
Understood, sir.
No, oh, yes or no?
Yes, sir.
Yes. Right. Then Sajini, what about that? I do not hear you.
I understood, sir.
Yes. Devmini, you want? Yes. What about Devmini? Yeah, understood or not? Yes or no?
Yes, sir. Understood.
Yes, okay. Tarushi also understood. All right, good. I'm happy with you. Actually, this one is a little complex. It get complex, right? Calculate the weight of the object in the air, right? Right. I'll get that. You can find this object. Okay. It is 8 Newton. 8 Newton, it gets children after giving the 3 Newton to the here children. When you are giving the 3 Newton to here, up it becomes the 8 Newton. But when in the air children, when the object is in the air children, no upthrust children. Objects that is in the air, that 8 we have got with the 3 Newton upthrust we are having, right, in the water children. But in the air we do not have this 3 Newton. Then what happened? Another 3 Newton is going down. Plus another 3 Newton. 9, 10, 11. Now it will become 11 Newton. Right? Because upthrust balanced this Newton to the air. In that case, it will become the 11 Newton. We can write weight in air, weight in liquid. Okay, right? Equals 8 Newton. Up plus we got 3 Newton, up plus by water. In air, no up thrust. Therefore, weight in air. Air equals 8 Newton plus 3 Newton equals 11 Newton. Okay. You have to mark like that also. Then you find the more and more question on this one, because actually these are considered as the most difficult thing, because very easily children don't understand these things. What the mass of the object in the air? Because actually earlier also I gave similar things coming for the questions in the physics. W equals mg. Mg. Then mass equals W divided by G. Weight is 11 Newton. Then the G means the acceleration due to gravity. 10 meters per square second. In the 11 divided by 10, 1.1. 1 kilogram. Mass we measure with the kilogram. Weight we measure with the Newton. Right. Have you done that, children? Or finish recording this, right? Then to find the density equals mass divided by the volume. Mass is 1.1 kilogram. The volume of the object 300 cubic centimeters. We have got it here. Object is 300 cubic centimeter. Volume of the displaced water also 300 cubic centimeters. Then 300 cubic centimeters. Cubic means height, width and the length. Right? All they are multiplied, we get the cubic centimeter. Centimeter. There. Right? To convert centimeters into meters, we have to divide by 100, because 1 meter gets 100 centimeters. 100 centimeter equals 1 meter. In that case, to convert this one into meter, we divide it by 100. To convert this centimeter into meter, that's also we divide by 100. And to convert this centimeter also into meter, we divide it by 100. And after simplifying, children, this 2 we cancel with this one. Then 1 goes to if you get 1, it goes to 1 decimal point. And another 1, 2, 3. Then we get it as 0.0003 cubic meters. At 1.1 divided by the 0.003. After simplifying, children, we get 3666 kilogram is up. In the cubic meters down, when it is going up, we get the minus. What's happening, children, then? This one. Right? It's a very nice thing, because I have designed these questions to explain the basic theory. if you cut the thread hanging the object, will it float or sink there in the water? Right? I'll show the other page. If you cut this thread, children, it is floating or sinking in water. What will happen, children? You answer. What is Sajid? If you cut this thread, what will happen this object, children? It will sink or float. What about Devmini? If you cut this thread, what will happen? It is sinking or floating. Pavani?
Sinking.
Yes, it is sinking, children. One thing there, right? I got the density here. According to that, we got the density of the water, children, as 1000 kilograms per cubic meter. One thing, right? We calculate the density of water according to the data collected in the experiment. 1000 kilograms per cubic meter. And in this object, children, we get the density, right? 3666 kilograms per cubic meter. The object is denser than water. That's a one thing. It is sinking because when the object is denser than the water, it is sinking. The smaller classes also you have studied, right? That one we can get another thing, right? The water applies an upthrust, right? Sometimes children leaving and joining, but due to the connection and the electricity problem, but refer the video, right? I'll send you, right? Another thing for sinking, children, the upthrust is 3 Newton. But weight of the object in the air 11 Newton. To float, children, upthrust also should be the 11 Newton. Upthrust 11 Newton. Sorry, the weight of the object is 11 Newton. Upthrust 3 Newton. The weight of the object is greater than the upthrust applied by the water. Two things. One thing, the object is denser than the water. Water, we have calculated and get the density 1000 kilograms per cubic meter. But this one we have calculated and got the density 3666. Like that, children. In that case, the object is denser than the water. It is sinking. The other one, children, the upthrust applied by the water is less than the weight of the object. Okay, we will go to this page, children. If the object is, if you cut the thread hanging the object, will it float or sink? Yeah, floating. Right? You write it as floating. Floating. Explain the reason for the above question. There are two reasons, children, we can explain. One thing, the upthrust, the weight of the object is greater than the upthrust applied by the water. Right? You can write weight of the object is greater than then greater than the upthrust applied by water. So one asks, another thing we can tell, the object is denser than water. The density of the water we calculate and got 1000 kilograms per cubic meter, but this object is still much denser than that, 3600 like that, right? The object is denser than water. Down we can write the density of the object is greater than the density of water. Right. Finished, children, right? Okay. We understood, children, that's not only your eye and the ear, your brain also should be processed with. We'll do that, right? First we'll read that. Carefully understand, it's also having a more good questions there. Gas also creates a pressure. Okay. We'll read it. That gas molecules collide with the walls of the container and make the pressure. Here, these gas molecules, children, they are coming and touching the walls of the container. That gives the pressure. This one touching here, this one touching. These gas molecules are there. They are freely moving. These gas molecules, they are touching the walls of the container. That creates the pressure. Right? The gas molecules collide within the walls with the walls of the container and make the pressure. The other one, children, they are touching each other. Right? This one and this one touching each other. They do not make the pressure. Right? When touching the molecules each other, it does not cause the pressure. When the molecules touching the walls there, right, it makes the pressure. But again, the bus has stopped there, right? And because carefully understand, for the MCQ they are asking, gas also creates a pressure that gas molecules collide with the walls of the container. You have to highlight gas molecules collide with the walls of the container. Right? And makes a pressure on the wall, right? That's why balloon also getting filled. They are coming and colliding the walls of the balloon. But collisions among the gas molecules do not create a pressure. When more gas molecules in the container, it makes more collisions between the gas molecules and the walls of the container. More gas molecules, it's more collisions there. In that case, it's having a greater pressure. Those container creating a high pressure inside it. The more molecules are there, it's a high pressure. The small number of molecules are there, it's a low pressure. And these factors consider the pressure there. It's a temperature. Right? When the temperature is rising, they are moving much faster here and there. In that case, pressure is high. And the number of gas molecules in the unit volume, that means number of gas molecules there. The more gas molecules are there, more collisions are there. Right? That is, it gives the atmospheric pressure. It makes the pressure. Atmospheric pressure means, children, now the other part, children, atmospheric pressure. Pressure in the air also creates, so air in the pressure, sorry, air there, right? Air in the atmosphere. That is known as the atmospheric pressure. You can find air in the atmosphere also creates a pressure. The atmosphere here and there around us, children, we are having the air, children. This air also creates a pressure on us there, right? That's called the atmospheric pressure. Air around us also makes a pressure on our body. That's known as the atmospheric. Did not record that part there, right? Okay. We will tell, we can measure the atmospheric pressure with this barometer there, right? We can get that one. We measure it because 76 centimeter to convert it, because the pressure by this mercury column, it is due to the atmospheric pressure we get there. Then we get this value 760 mercury millimeters. Right? We can tell. But at high altitude, you understand, when you are going to the higher places in the Norelli-like area, atmospheric pressure is very low. Highest atmospheric pressure you can get at the sea level. On the top of the Everest, atmospheric pressure is 25 mercury centimeter. Under the high atmospheric pressure at the sea level, we get the 76 mercury. Water boils at 100 degrees centigrade. Right? Because actually water boils at the 100 degrees centigrade, children, at the sea level, children, 76. But in the top mountains under the low atmospheric pressure, water boils at the lower temperature than 100 degrees centigrade. Because you can understand, if you go to Norelli and other areas, you boil the water and see the temperature, it is lower than the 100. When you are going lower and lower atmospheric pressure, water boils at the very low temperature. When the atmospheric pressure is high, water boils at the very high temperature. Yeah. At the sea level, it's boiled at the 100 degrees centigrade. If you get the pressure meter, pressure cooker, its pressure is very high, children, than the atmospheric pressure. In that case, water boils, children, at the boiling at the 120 degrees centigrade. That's why we can cook well, and we can boil grams, kadala like thing at the very nicely, because the temperature rising more than 100 there. Because the pressure is very high than the atmospheric pressure in the pressure cooker. Yeah. And we will go to the other part. And I have added some questions here. If you use water as a liquid to make a barometer, what will be height of the water column when you measure the atmospheric pressure? That is the you try to do this, children, as a homework. Again, I will explain it. Compare the advantages of the mercury as a liquid in the barometer. And you have to think, you try to read the book and try to find that. Okay. Here we are using the mercury in the barometer. Find what are the advantages and the disadvantages there, right? We get more time for this one again. Next week also I am explaining that. Okay. And the aneroid barometer. Aneroid barometer means it's a mercury is difficult to use there, children. That's a liquid, children. Thereafter, children, there some barometers are there. We can take it to the different places there, but that one difficult here. Take from place to place. We are using a scale like barometer there. That's called the aneroid barometer. Okay. Here, this one and this is an aneroid barometer. No? We can use at the different places as a antique like one here to use it. In that case, it is changing the scale according to the altitude there. It's an aneroid barometer. And some applications based on the atmospheric pressure. Right? What are the things, children? Drinking a liquid, right? Drawing a liquid to the syringe. You can understand from the syringe, children, we make low pressure inside the syringe and get siphon, right here. From the upper part place, children, we are taking the liquid as that. And drinking Coca-Cola with the straw, right? We make a low pressure inside the mouth, and here atmospheric pressure, it is coming there. And the suction, rubber suckers, like that, you can find that in the motor vehicles windscreen. We can place that. We remove all the air inside that. Here to here, we are giving more atmospheric pressure. From the inside, no pressure. It is touching there. If air leaks, it remove there. But if you tightly touch that, all the air goes out, only outside atmospheric pressure applied there. It is difficult to remove that. Rubber sucker.